U.S. drones evolved from Cold War reconnaissance systems to modern multi-role platforms used globally for surveillance and strike missions. Early models, like the Ryan Firebee, served in Vietnam for reconnaissance and target practice roles. The 1990s saw breakthroughs with the MQ-1 Predator, integrating cameras and Hellfire missiles for real-time combat capability. The larger MQ-9 Reaper expanded range, payload, and endurance, becoming central to U.S. counterterrorism operations. Global Hawk drones conduct strategic reconnaissance with endurance exceeding 30 hours at 60,000 feet, RQ-4. Global Hawk is a high-altitude, long-endurance, unmanned reconnaissance aircraft by Northrop Grumman. Designed for strategic intelligence, surveillance, and reconnaissance (ISR) missions across vast areas. Equipped with synthetic aperture radar (SAR), electro-optical, and infrared sensors for all-weather imagery. Pre-flight inspections ensure aircraft safety, reliability, and mission readiness before every flight. Ground crews visually inspect the fuselage, wings, and control surfaces for damage, leaks, or obstructions. The RQ-4, Global Hawk's taxi and takeoff are fully controlled by ground operators from a mission control station. Ground controllers use a secure data link to guide the drone along taxiways toward the active runway. Sensors and onboard cameras provide situational awareness to avoid obstacles in ground traffic. Just for backup, the RQ-4 pilot in a chase vehicle flows the aircraft on the ground while taxiing. Upon receiving takeoff clearance, the throttle is advanced to full power, engaging the Rolls-Royce AE 3007H turbofan engine. Rotation occurs automatically at the calculated speed, lifting the Global Hawk into a steady climb. The aircraft accelerates smoothly, guided by pre-programmed flight control software rather than manual input. Landing the RQ-4, Global Hawk is an automated yet closely monitored operation guided by mission control. The aircraft automatically configures flaps and landing gear for approach and touchdown. XQ-58. A Valkyrie is a next-generation unmanned combat aerial vehicle developed by Kratos under the U.S. It is engineered as a cost-effective, stealthy, loyal wingman, capable of supporting advanced fighters like the F-35 Lightning II, designed to operate semi-autonomously. The Valkyrie can accompany manned aircraft into high-threat zones while minimizing pilot risk. Unlike traditional aircraft, the Valkyrie is launched using a rocket-assisted takeoff rail and recovered by parachute, requiring no runway. Capable of reaching speeds up to Mach 0.85, it offers a range exceeding 2,000 nautical miles for deep penetration missions. This flexible design enables rapid deployment from remote bases, naval vessels, or forward operating locations. It can fly pre-programmed routes, perform electronic warfare, relay data, or scout enemy defenses before manned fighters engage. Developed to be attritable, it balances advanced technology with low unit cost, allowing commanders to deploy in high-risk missions. Recovery methods emphasize affordability, using parachute or minimal infrastructure retrieval for rapid turnarounds. Program focuses on low unit cost, allowing risk-tolerant deployment in saturation or suppression missions. Successful tests demonstrated autonomous formation flight, weapons delivery coordination, and secure teaming with manned platforms. At Repmus and Dynamic Messenger in Portugal, NATO's Diana partnered with allied militaries, tech firms, and researchers. The exercises focused on transforming emerging technologies, such as AL, robotics, and autonomy, into practical assets for NATO forces. Prototypes of unmanned systems, data sharing tools, and maritime sensors were evaluated under real-world operational stress. The collaboration showcased Diana's mission to bridge innovation with defense needs to deployable capabilities. These experiments reinforced NATO's drive for technological superiority, resilience, and readiness across complex, multi-domain operations. UAV testing during Repmus and Dynamic Messenger evaluated autonomous flight, maritime surveillance, and multi-domain coordination. Robotics testing at Repmus and Dynamic Messenger explored autonomous surface, aerial, and underwater platforms. The Kellu airship is a Finnish-developed, helium-filled hybrid drone designed for long-endurance surveillance missions. It combines lighter-than-air buoyancy with electric propulsion for stable, energy-efficient flight. Capable of remaining airborne for days, it provides persistent monitoring over wide areas. The Schiebel S-100 camcopter is an Austrian-made rotary wing, designed for intelligence, surveillance, and reconnaissance. It can take off and land vertically without a runway, ideal for shipborne and remote operations.